FM Synthesizer Module Assembly, Part 1. Having built the prototype and tested the hardware, I am now looking to the next stage in the build. The time has come to decommission the prototype and get the first of the final design units built and mounted on the frame. I am also running out of desk space, so it's reached a point where this needs to become a priority. The boards were designed and manufactured months ago. I also have most of the parts already. It's a fairly complex build and I don't have a strategy for it yet. So the first thing I needed to do was break the task down into a number of steps so that I have a plan to work to. With the plan developed, it's now time to design and print some mounting parts. The ESP32 mounts attach to the board with double-sided tape and will eventually be taped to the ESP32 board. There will be two of them, one for each end of the board. These are necessary because of two unforeseen issues. Firstly, the footprint for the ESP32 module I am using was actually about 1 centimetre too narrow. When I chose the part in TinkerCad, I confirmed that the pinout was correct, but had not expected that the board came in two different sizes. Secondly, I recently found out that the ESP32S3 boards can have a MIDI keyboard plugged into the USB socket, but I did not allow for USB connections in the design, so the LCD connector is blocking the USB sockets. I am using stackable headers to raise the height of the board so that the USB sockets clear the LCD connector. The main board mount attaches to the potentiometer panel using double-sided tape, allowing the main board to be slid into a slot, then lowered into its socket at the other end. The DAC is mounted on a separate board so that changing a single board is all that is necessary to change to a different DAC type. As with the main board mount, this is also attached with double-sided tape and the board is fitted into a slot, then hinged down into its socket. The potentiometer board was assembled some time ago and has been sitting around waiting for the main board to be assembled. The front panel is a near perfect fit for the potentiometers and the board is currently held in place only by the tightness of the knobs. In the future, I will come up with a better solution. Here is the front panel with all the knobs holding it together. Here you can see the mount for the main board. I made the feet too large, so I had to correct the design. Rather than waste filament, I filed notches for the solder pads. Not pretty, but I don't like waste. Here is the main board. Note the stacked headers being used to raise the height of the ESP32 board. Note also the 5 DuPont pins fitted to the overhanging pins. Luckily, I had not used many I/O lines on that side. In fact, 3 of the 5 pins are just ground pins. Once pressed into the socket, it fits nicely and the tops of the two printed mounts will eventually have double-sided tape placed on them to secure the ESP32 in place. You can see here the all-important clearance for the USB sockets. Now for the DAC board. After some fumbling, it's fitted. The actual assembly of the DAC board will be done later, as I still need to order the DAC breakout board from China. Now, to fit the main board to the potentiometer board. As with the DAC board, just hook it in place and hinge it down. I'm probably going to go postal with the hot melt glue gun once it's working. The LCD board will be next. It is currently covered in clothes pegs waiting for glue to dry. Let's look at an exploded view of the design. This is the front bezel, which is built into the control panel. This is the frame. It is glued to the bezel using an upper and lower flange. The LCD module sits inside the frame, and adjusting the position during the gluing process allows the LCD to be accurately positioned. This is a mock-up of the LCD module. The white section is the actual display, the green section is the PCB, and the red section is the 14-pin header that connects to the display. Next is the spacer. It sits behind the display and applies holding pressure to the LCD and has cutouts wherever there are components on the board. Finally, we have the backplate. It is glued to the rear edge of the frame, holding everything together. The pins protrude through it to allow easy connection. As the project only uses the first 10 pins, there is a cover that goes over the last 4 pins. A frame surrounds the 10 pins that are being used, and this forms into a holder for a standard header socket. This allows a cable to be plugged straight into the LCD module. As the rear panel is quite thin but needs to be rigid, the large flat area includes a mounting frame for a standard Vero board to be snapped in place. This also has the benefit of providing much needed real estate. Here is the mounting hole for the DB15 HD connector. Here you'll see the pins lining up with the socket frame. Here is the mount for the Vero board. Now I'll skip the gluing and show the final assembled unit ready for all the wiring. This is my favourite part. The 10-pin header plugs in perfectly. In the next episode, I will cover the wiring. It will be a few weeks away because I have parts on order from China still.